Assalamualaikum and a very good day to everyone. Today, our topic is about Introduction to Mathematical Economics. My name is Siti Ashariskina binti Muhammad Muslim. My number matric is 284794. I'm from Group A. I'm taking course Bachelor of Science Economics, Sem 1. In the question 1A, determine phi side of second derivative in each internal by computing second derivative C, where C is any chosen test number in the interval. To solve the question, step 1 is differentiate using the power rules. By using these rules, we can then get the first derivative of the fx function, which is equal 3x squared negative 12x plus 18. Next, we're using our power rules, and here is our second derivative function which is equal to 6x minus 12. Second step, let the second derivative of x equal to 0 to find the interval, so let's add 6x minus 12 equals 0. So we can get x equal to, so the interval is negative infinity to 2 and 2 to infinity. First, we list down the interval and select the test point between the numbers in the interval. Then we substitute them into the second derivative function and we get negative value and positive value. The negative value means that the function is concave downward, meanwhile the positive value means the function is concave upward. Determine whether the function is concave upward or downward. So if value of second derivative function is greater than 0, so it concave upward. And if the value second derivative function is less than 0, so it concave downward. For the question 1b, let's have a look. They suppose that the cost function for a manufacturer is given by Cx. Describe the behavior of marginal cost function. For the question 1b Roman 1, in order to find the marginal cost function, we divide the cost function into 0.00003 x power 2 minus 0.006x plus 5. For the question 1b Roman 2, hence, the concentricity can be determined if we let the second derivative of the cost function equal to 0. X is 1000, which is the interval are negative infinity, 1000 and 1000 infinity. We list down the interval and select the test point between the number in the interval to identify where concave outward or downward. Thus, the function is concave downward, meanwhile the positive value means that the function is concave upward. Moving to our last question, the revenue, cost and profit function. So the question is, a company has established that the revenue function in Ringgit Malaysia is equal to 2x power 3 plus 40x power 2 plus 8x. And the cost function in Ringgit Malaysia is equal to the 3x power 3 plus 19x power 2 plus 18x minus 800. For the question 1c Roman 1, to find the production level that maximizes profit, we need to find the profit function. So, to find the profit function, we use total revenue minus total cost. And here what we get to for our profit function. We can now find the first derivative of the profit function using these power rules as previously mentioned. So, this is what we will get, and let it equal to 0 determine the level of production that we maximize the profit. That the first derivative of profit function equal to 0 to find the level of production, and we will get two level of production, which is x equal to and 12. To find the exact unit that maximize profit, we need to find second derivative profit function, which is we will get that equal to negative 6x plus 42. To know is this a maximum or minimize or an inflection, check using the second order conditions. Then we insert the value 2 and 12 into second derivative of profit function. We will get 30 when the production level is 2 or negative 30 when the production is 12. So when the level of production is equal to, the number obtained is 13, which is greater than 0. It is the not minimized level, which is when the number of production is equal to 12. The profit function is negative 13, which is less than 0. It is the maximum point. The level of production that we yield a maximum profit for the company is 12. For the question 1C, Roman 2, to find the price per unit that maximize profit, so we can use back the level of production which will maximize the profit, which is 12, and insert into the profit function and divide by 12, and we will get the profit function and we will get the price per unit that maximize the profit is RM102167. That's all for me. Thank you for listening.